already gone over the introduction to what wastewater management is. That's kind of what's summarized in this first page here. So remember, this is all about the affordable house. So you got to make sure you look at your affordable house design and go through. As we go through, I'm going to use my examples, so my elevations and stuff like that, which might be a little different than yours. All right, so some basic information. The invert elevation at the sewer main is 14 inches. And not the elevation. The pipe is 14-inch diameter pipe, sewer main, and then the elevation is 763.15. All right, so if we just draw a quick sketch to understand what that looks like, we're going to do that here. So we've kind of seen this in our PowerPoint. So that's the exterior wall. This is our floor. This is our foundation wall coming down. And then you have, it's a little bit too big, your footing. And then through here, let me change colors. You have your sewer. All right, and this is your lateral. And another important thing to put on here is your ground elevation. And then your sewer main. And some other stuff that's really important, that elevation right here. That's your building. Invert elevation. This is your sewer main invert elevation. If I carry that all the way over carefully. Oops. Let's try that again. That right there is my change in elevation. All right. So this first problem here, calculate the approximate crown elevation of your existing 14-inch sanitary sewer main. So the crown, that is the top right here. All right, so that's your crown. The whole point is we want to make sure the sewer main is underneath the frost depth. So we're going to need to figure out eventually what that depth is there. But this here, the sewer main invert elevation, that's always to the center of the pipe. So we have to add the crown is equal to the invert plus half the diameter. So crown is equal to 763, I think it was 0.15. Yep, 0.15. Plus half of 14 inches. Well, you can't add feet and inches, so you got to convert inches to feet. And you would get 763.73 feet. Okay. And that's 763.73 feet. This is 763.15 feet. All right, assuming the building sewer must connect to the main on 10th Street, determine the horizontal distance. This is going back to the plan. I don't have my plan pulled up here, but I'll tell you when I went to Revit and figured this out, for me, my distance is about 94 feet. All right, so what I'm saying is from here to here is 94 feet. And this is where you have to figure it out for yourself what yours is. All right. Determine the minimum size allowed for the building sewer lateral using this example residential plumbing code. So we've seen part of this code right here, this table, but that's only part of the table. If you actually go to the code, this code right here, It's just a part of a code. You have your water supply, and then you have sanitary drainage. All right, so the part of the code you see is this top of the table. If you want to go through your house item by item, toilet by toilet, sink by sink, and all that, you can do that. Or if you use the bottom of the code that's not in that PowerPoint, you can kind of just do it room by room, which is really nice. So you can see like the first one, a full bath group with bathtub with a 1.6 gallon per flush, like the low flow toilets, which is what we're using. You have 5 drainage fixture units. We're not using a full bath with a larger toilet. I don't have any half baths. I only have full baths. And then a kitchen, I've got one of those, so 2 there, and laundry, I've got 1 there, so that's 3. So I've got 2 full baths, 5 each, so that's 10. A kitchen is 12, and a laundry, that makes it 15. So let's just document that real quick. So I have kitchen. That's 2 drainage fixture units. I have laundry. That's 3 drainage fixture units. And I have bath. 2 times 5 drainage fixture units is 10 drainage fixture units, making a total of 15 drainage fixture units. All right. And then to size the pipe, you go to the next table down, and I'm not going to use 1.5, 2, or 2.5. I'm going to use a 3-inch or a 4-inch. And you can see that if I want to use a 3-inch, I can have up to 36 drainage fixture units and have a 1/8 inch slope. Well, that's great because I have less than half of that. So I can use a 3-inch pipe at 1/8 inch per foot slope. Okay. All right, determine the maximum building sewer pipe invert elevation. So if we go back up to here, what we're designing right now, oops, undo that. I want to highlight, oops, I keep on hitting erase instead of highlight. I want that elevation right there. So I'm kind of back calculating from here, going back up now. I know I have 94 feet at 1/8 of an inch per foot to figure out what the elevation needs to be. All right. So and also I need to make sure that it is at least a certain depth here, that it's under the frost elevation. Okay. So I need to account for frost, and I need to account for the slope. Okay. So if I follow that link, it'll take me to this document here, this website here. Noblesville, Indiana is in Hamilton County. Hamilton County is the light blue, which is 54 inches. All right. So frost is 54 inches, which is 4.5 feet. So I know my bottom of floor elevation is 769.5 feet minus 4.5 feet. So 769 minus 4.5 feet is, let's see, 765 feet. And then, so what that did is that took me to the top of my pipe. I need to go down to the bottom of my pipe. So subtract 3.5 inches. Sorry, not 3.5, 3 inches. Let's try this again. 3 inches, but I can't, again, do inches and feet, so divide that by 12. So minus a 1/4 foot gets me to 755.75 feet. Oops. All right. So based on frost, it has to be at least that deep. that's based on frost. Based on slope, I need to kind of work my way back. So remember, I had to do, so the sewer main is at 763.15. So 763.15 feet plus 94 feet times 1/8 of an inch per 1 foot. 1/8 of an inch is 0.125. So 94 times 0.125 is 11.75 inches. So 763.15 feet plus 11.75 inches. Again, I can't add feet and inches, so divide that by 12. So divide that number by 12. And you get 763.15 feet plus 0.98 feet. So 763.15 plus 0.98, 737.13 feet. So in order to meet frost, I need to, the highest, this is the highest my pipe can be, is 755. To meet the slope, this is the lowest it can be. As long as I'm somewhere in between that, I'm fine. All right, so there we go. What is the minimum slope allowed? I kind of already did that. The minimum slope is from, let's see, where was it? Part D. C number 1, part D. Code requires 1/8 inch per foot. I already did that. There we go. And that's it. So that's how you do those example problems there. And again, the big one here, the really important one is this one here. I just want to kind of reiterate. As long as I put my building invert elevation somewhere between, so higher than 737.13 and lower than 755.75 feet, I'll be fine. I mean, you have quite a ways there. So, you know, you can use whatever elevation you want. If you have a base